and gentlemen, welcome to yet another interesting lesson number 4, where we are going to discuss about rational equations, quadratic equation, and the quadratic form. All right. So what is a radical equation? So a radical equation contains variables in radicals. So radicals are square root, cube root, etc. So these are powers of reciprocals or powers of the form 1 over a, where a is an element of, where a is an integer, where a is an integer, positive integers, where a is a positive integer. So the general solution approach is to isolate the most complicated radicals. Then you raise both sides to the power equal to radicals index. Then you solve the equation. The last and most important step is to check for extraneous solutions. So you need to always verify your solution, as raising of powers can introduce extraneous roots. So what are extraneous roots? So these are roots which may not satisfy the given equation. So these are extraneous roots, cannot satisfy the given equation. For example, if you are given a radical equation of this form and you want to solve this, so you take this to this other side. Since it's negative, it will, if it jumps the equal sign, it becomes a positive, or you can add to both sides. And then from there you raise to the highest radical index. In this case is 1 over 3, so you raise both sides to the power 3, so it will cancel this side. Make sure you see this as a 2x minus 4 to the power 1 over 3. So multiply both sides, you get this, and then 2 to the 3, you get that. And then you bring this other side, so it will be plus 4. So you get 12, and then divide by 2, you get 6. And then you check, you verify your solution. So if you substitute 6 there, this will be 12 minus 4, which is 8. Cube root of 8 we know is 2. Then 2 minus 2 is 0. So your solution set will contain this value 6. And then the next one, where you are given a radical on the left hand side and an expression x minus 7 on the right hand side. So you raise to the power, remember square root is the same as raising to the power half. So you raise to the power 2 both sides. So here you remain with x minus 1. If you expand this, you get x squared minus 14 plus 49. And then if you bring all terms to one side, you get x squared. This one will be minus minus. So it is minus 15. This will add, so it will be 50. And then from there you factor. Remember, this is a 1. So you want two numbers such that we multiply, we get 50. We add them, we get minus 15. So 5 times 10, 5 times 10, minus 5 times minus 5 minus 10. If you add this, you get minus 15. If you multiply, you get this. Then you substitute in place of minus 15 and then you factorize to get this. To factorize this, you get your solution as x is equal to 10 and x is equals to 5. Then you check for extraneous solutions. So this will be, if you substitute for 5 there, so this is 5 minus 1, which is 4, which is square root of 2, and then 5 minus 7, you get minus 2, meaning to say the left hand side and the right hand side are not equal. You have an extraneous solution, and then you also have x10. So for this is 10 minus 1, 9, square root of 9, 3, 10 minus 7 is 3. So this is a real good solution to that problem. It's the only solution to that problem. Then we've got next two, we have quadratic form equation, quadratic form. So an equation is quadratic in form if it can be written as a u squared plus b u plus c equals to 0, where u is an algebraic expression. And then the solution for getting the strategy for getting the solution, you identify the substitution for the expression u, and then you rewrite the equation in terms of u. Then you solve the quadratic equation, then you substitute back and solve the original value, then you verify the solution. Let's have an example to see that. So suppose you are given x plus 2 squared plus 11x plus 2 minus 12 equals to 0. Clearly you see this expression by observation or by theory of velocity. You then let your u be equals to x plus 2. Then your u squared will be x plus 2 squared. So making that substitution, this one will be u squared. Then this one will be u. And then the quadratic form will be given like that. And then you look for two numbers such that you multiply, you get minus 12. And then you add, you get 11. So if you multiply, you get 12. So this is minus 12, no, 12 and minus 1. 12 times this minus 12, 12 minus 1, that's 11. So these are your factors. And then from there, you get your u equal to minus 12 and the other u equals to 1. And then remember, your u is x plus 2. So you substitute this back there. Control. So you substitute this x plus 2 equals to 1. So you solve these two should get minus 14 and minus 1. Then you need to verify this whether this is true. So if you put minus 14, if you put minus 14 for x there, minus 14 plus 2 minus 12 squared, 144 plus 11 times minus 12, that's 132 minus 12. Sorry, this is minus. So if you add this and this, you see this will give you 144, 144. So this is 0. Similarly, this is minus 1. So minus 1, there 2, that's 1. And then this one, 1. So this plus this 12, so this is 0. So your solution set contain both of those values. And then if you are given x plus 2 square root of x minus 3 is equal to 0, here you should see this as, you should see this as you should see x as the square root of x squared. Remember, square root is just raising to the power half. So you should see this equation as square root of x squared, which is x, this is x, plus 2 square root of x minus 3, this will be 0, such that you can then take this substitution where your u is square root of x and the u squared is x, and then from there you can then factor. After substituting, you can factor two numbers such that you multiply, you get minus 3, you add, you get 2. So this is 3 and minus 1. So then you substitute back for u. In this case, you get this guy. Yeah, no, sorry, no. If we are saying no, then we should say no real solution. Otherwise, the solution is complex. Remember, we did complex numbers, so this will be x is equals to, in the complex setting, this will be a, this will be a, you square both sides, so this is what, 9. So if you square both sides, this you get 9. Yeah, you square, you get 9. Why are we saying no solution here? Here I made a mistake. So this should be 9. Then this one, you square both sides, you get 1. Then you verify this. You can verify this. So 9 plus then 2 square root of 9 minus 3. Remember, square root of any number is 9 plus 2 plus or minus 3 minus 3. So this one minus 2 2 times 3, that's 6, and then 2 times this, it's minus 6 minus 3, so minus 3 is is a solution, and then 3 is not. So your solution set should have 1 minus 3. Sorry, this should have 1 and then for these other examples, you can have a look on them, pause the video and study and go through these other examples. So in summary, a radical equation require isolating the radicals and raising to the power of the radical index. Always check for extraneous solutions, and then equation quadratic in form. You look for substitution opportunities, then solve quadratic, then back substitution again, and then the factoring method, you bring all terms to one side, then factor completely, and then use zero product property. Verify your answer always, this is always crucial. And then the next step or the next lesson, practice identifying which methods applies to different equation types. Thank you. Share, like, and comment.